Hello everyone, welcome back to my channel, and this time we are doing part 4 in the series of organic chemistry. I am the tutor doctor from DV Tuitions, and in this video we are going to look at alkenes, their structure, their general formula, and most importantly their reactions, which are extremely important for your GCSE triple science exam. This lesson is suitable for students. You can start early as around as year 9 onwards, and it's especially useful if you're preparing for your GCSE chemistry or any foundation level year 12 chemistry as well. We will begin by understanding what alkenes are and how to recognize them. We will move on to their reactions, including combustion, hydrogenation, halogenation, and the bromine water test. I will also explain these reactions using the displayed formulae so you can clearly see what's happening at the molecular level. Now, towards the end of the video, I will also briefly compare alkenes with alkanes and explain why alkanes are less reactive, something examiners often like to ask in the GCSE exams. I'll also finish off with key exam tips and types of questions you're likely to see in your GCSE exams. So all my fams, make sure you have a pen and paper ready, pause the video when needed, and let's get started. Now, what are alkenes? Alkenes are compounds which have the signature double bond. They are unsaturated hydrocarbons. Now, what are unsaturated hydrocarbons? Now, imagine a situation, fams, where all of you were hungry. You just have space for that one another dessert in your tummy, or one another dish. You're out with your mates, you're still feeling a bit hungry, not so much, but you can have one more bite. Exactly, that's the case with unsaturated hydrocarbons. So you can identify any compound as an alkene. The signature is a carbon-carbon double bond. Even a compound has, let's say, 10 carbon atoms in it. Even any two of those out of 10 carbon atoms are double bonded, at least one carbon-carbon double bond. So that's how they look. One carbon-carbon double bond, then we can call that compound as an alkene. The general formula of an alkene is CN. Again, as I told you in my previous videos, N represents the number of carbons, H2N. If you compare and if you remember, pause here and remember what is the general formula of an alkane. Absolutely, you got that right. It is CnH2n plus 2. Whereas for an alkene, you can see there are 2 less hydrogens than an alkane. Why? Because there is a carbon-carbon double bond, and this is the key reason they call them unsaturated. Remember my being hungry example? So an alkene is hungry for 2 more extra hydrogens, or 2 more elements to be added across the compound when the double bond is broken. That's why alkenes are known as unsaturated hydrocarbons. And why are alkenes more reactive? The double bond is the reason for alkenes being more reactive. So for example, if I take ethene, the molecular formula for ethene is C₂ₙ Remember from my previous videos where I taught you prefixes based on the number of carbons. Eth means 2 carbons, so ENE representing that it belongs to the homologous series of ethene. Now, if we look at the displayed formula, you have a carbon-carbon double bond, and rest of the bonds are with hydrogen. Now, again, as I've mentioned in the previous videos where I was teaching you about alkanes, carbon is in group 4 of the periodic table, so therefore the maximum number of bonds it can form are 4. So whenever you're writing your displayed formulas, if you're not confident, all you need to do is count your number of bonds. each carbon should only be having 4 covalent bonds. Now, let's get to the reaction of alkenes. Now we are going to see what are the different reactions of alkenes. The first one I want to talk about is combustion. Now, what is combustion? In English, the word combust is to burn. And in chemistry, combustion means complete burning of a compound within the presence of oxygen. So for combustion, it's important you have plentiful supply of oxygen. Any combustion reaction on the face of this earth, whenever you're writing any combustion, the products are always carbon dioxide and water. Combustion reaction always releases energy. That is why whenever there's a fire accident, you would see a lot of damage is because when the fire, it is burning in presence of oxygen, a lot of energy is released. Now let's take butene. So butene plus oxygen is giving us carbon dioxide plus water. So I've written a mixed equation, so I'm going to give you a balanced symbol equation for this. 2C4H8, C4H8 is our butene, is burning in presence of 12 oxygen molecules, giving us 8 molecules of carbon dioxide and 8 molecules of water. Always remember for exam, complete combustion produces carbon dioxide and water. Now, let's talk about addition reactions here. Now, meanwhile, I'm pausing you so that you can quickly, in your mind, go through what I said about combustion of alkenes. Now, one more point I want to add before we move on to addition reactions is sometimes there's incomplete combustion. So what does that mean? So if there's incomplete combustion, there's also complete combustion. So complete combustion occurs when there's excess oxygen, so water and carbon dioxide are formed. But there are situations where there is incomplete combustion. So I would like to teach you about that before I go ahead and talk about addition reactions. So let's say we have same butene. Instead of 12 oxygen molecules, imagine if butene had only 4 oxygen molecules supplied to react with. Then it will form carbon monoxide and water. Yes, you have recognized it right. It is that toxic gas, carbon monoxide. So when there's insufficient oxygen to burn, a mixture of products can be formed. Let's say, in addition to carbon monoxide, if you can say to the doctor, what happens if there's still less oxygen? So let's say we only have 2 molecules of oxygen, then we will form soot, that is carbon, and again water, right? And this is more likely to occur in higher alkenes with large number of carbons, and it is seen as smoky yellow flames when the alkenes burn. Now let's go on to addition reactions. Now, in addition reactions, the whole of the reactivity is based on the carbon-carbon double bond. Now, all members of the alkene homologous series contain the same functional group. They all react similarly. So all of the alkenes undergo addition reactions in which atoms of a simple molecules are added across the carbon-carbon double bond. So the carbon-carbon double bond opens up, it gets broken. It forms a single bond between the carbons, allowing 2 more atoms to bond onto each other carbon. Now remember, in this reaction, only one product forms. There are no byproducts. So addition reactions are a big GCSE favorite. So if I have to kind of give you a general template, I'm again going to take ethene as an example. Now I've drawn the displayed formula of ethene. Let's say I'm adding an imaginary molecule XY here. Now from an alkene, it is going to convert into an alkane. I'm going to add my XY across the ethene here, and I am converting it into an ethane. Imagine if my XY was just a hydrogen molecule, then I am going to add 2 more hydrogens across ethene, and then I've just made ethane. And this is what the addition reaction. But remember, adding hydrogen has got a special name. All right, and we will talk about hydrogenation. I'm just giving you an example, but in addition reactions, you can add halogens, you can add any compound across the ethene by breaking the double bond. Now, let's move on to hydrogenation. What is hydrogenation? Now, alkenes, as I told you, undergo addition reactions. Now, this is a special name given when they are undergoing addition reaction with hydrogen when an alkane is formed. So, hydrogenation reactions occur at 150 degrees Celsius temperature using nickel as a catalyst. This is an important piece of information for your exam, which you need to remember. Now, when do we use hydrogenation reaction? These are especially used to manufacture margarine. How many of you like that on your toast? I know it's an acquired taste, but this is made from vegetable oils. So vegetable oils are polyunsaturated molecules which are partially hydrogenated to increase the molecular mass and turn the oils into solid fats. Now, if you look at the displayed formula of ethene once again, it is similar to the one I have explained above. I'm adding hydrogen in presence of nickel as a catalyst, and as a result, I am forming ethane. And I hope it's all clear. From here, we are moving on to halogenation. Now, halogens, again, I've explained in my previous video, halogens are a group of elements. They belong to group 7 of the periodic table, and they participate in addition reactions with alkenes. Now, the same process works for any halogen and any alkene in which the halogen atoms always add to the carbon atoms, and then only to those carbons which are in the double bond. The double bond opens up, it's broken, and you can add your halogen. Now, halogens are diatomic molecules. So your group 7 elements, the chlorine, bromine, iodine, fluorine, all of them are halogens, and they are diatomic. What does it mean as diatomic? It means each molecule of the halogen has 2 atoms. Now, the double bond opens up and the 2 bromine atoms are added to the carbon atoms respectively. And now, as a result, we are forming 1,2 dibromomethane. Now, why are we calling it dibromo? I'm sorry, that's a mistake. It's 1,2 dibromoethane, not methane. And why are we calling it dibromo? Because we've got 2 bromine atoms added across on carbon 1 and carbon 2. And now, farms, we are moving on to bromine water test. Now, what is bromine water test? Alkanes and alkenes have different molecular structures. Now, alkanes are saturated. They're full. They have, the same example I gave you at the start of this video. Let's say you're completely full. You cannot eat one more morsel of food. But when you're a little bit hungry, you're able to push that dessert through. That's the difference between saturated and unsaturated. Alkanes, saturated. Alkenes, unsaturated. The carbon-carbon double bond allows alkenes to react in ways that alkanes cannot. Now, if I give you a sample in two different test tubes, in one test tube, I'm giving you, let's say, sample 1, and in another test tube, I'm giving you sample 2. Both of them have a liquid in it, let's say, which you don't know, but I did tell you one of them is an alkane, another is alkene. And how would you tell apart which one is an alkane and which one is an alkene? That's where a simple chemical test called bromine water test comes up. Now, bromine water is an orange-colored solution. When you add it to an alkane, it will remain as an orange solution, as alkanes do not have carbon-carbon double bond. So the bromine remains in the solution. But when bromine water is added to an alkene, the bromine atoms add across the carbon-carbon double bond. Hence, the solution no longer contains free bromine and it loses its color. So that's an important one, and you need to memorize this for your exams, and this is important. Now, one last important GCSE concept: alkanes are less reactive. And why? And often asked in GCSE exams. Alkanes are saturated hydrocarbons. They contain only single bonds. Single bonds are strong and stable. Therefore, they are not highly reactive, and it takes a lot of energy for alkanes to participate in chemical reactions. Therefore, they do not undergo additional reactions. They only undergo combustion and substitution reactions under UV light. So, in an exam, if they ask you why are alkanes less reactive than alkenes, alkanes are less reactive because they only contain strong carbon-carbon and carbon-hydrogen single bonds. So, one last revision at the end of the video. Alkene general formula. Say it out. Yes, you're right. CNH2N. Alkane general formula. Yes, you're right again. CnH2n plus 2. Alkenes undergo addition reactions. Alkanes undergo substitution reaction. Bromine water added to alkene goes colorless. And alkane, there is no change at all. Some of the questions you need to learn and memorize. What is the general formula of alkenes? What does bromine water test do? Name the product when ethene reacts with bromine. 3 to 4 marker questions. Explain why alkenes are more reactive than alkanes. Describe the bromine water test and its result. And 6 marker questions. Draw displayed formulae to show ethene reacting with hydrogen, ethene reacting with bromine. And thank you so much. I know this has been a bit of a long video. Thank you for your patience. And we will move on to the next topic in the next video. Until then, take care. Bye-bye.